Hello. Today, I will be demoing Embedder. Embedder is an AI platform that's designed for firmware and embedded software engineers. We found that a lot of traditional generic AI tools fail often at writing firmware or embedded software because of two main problems. One is they lack understanding of how the hardware platforms you work on actually works, the APIs of the SDKs, the documentation, the erratas, the reference manuals, anything that's needed for the AI to actually program on this processor. Generic AI tools like Copilot does not have, right? And needs to be provided externally through a user or another tool. The second thing is traditional AI tools has no way of seeing runtime behavior. This kind of makes the development loop using a traditional AI tool very fragmented, right? So the user has to manually paste in information, the user has to manually paste in logs after a build, and manually flash the board, which slows your iteration speed a lot down. And in Embedder, we have built an AI system that has the hardware knowledge and the hardware interaction capabilities to autonomously close this loop and autonomously iterate to a final result. So today, I'll be demoing this capability on an Infineon TC47 MCU, and we will be migrating an example from TC387, that's a simple application to generate dead time PWM pairs, to the newer generation AURIX processor. So the important thing here for the agent to understand is has to understand the new eGTM peripheral and understand all the changes related to that in order to generate the example on the TC4 successfully. So first, I'm going to paste in my prompt. So it's a very simple prompt telling it to migrate the example and telling it what pins I want to use. And Embedder now will start first by understanding our existing code base and also understanding all the documentation related to this task, right? So as you can see, we have two code base subagents here that's understanding our existing code base and the new empty code base, and also two document search subagents here, understanding the pin mapping and how the PWM signal can be generated on the processor. Our Embedder platform is also very interactive, right? So whenever there is a design decision, it will ask the user for feedback instead of just proceeding on its own and choosing its own direction. It will make sure its design decisions align with the user's intent. So after all the research is completed, it will write a migration plan. And this migration plan will be a specification file for the user to review. So the user and our Embedder agent can come to an understanding of the scope of the project, how to proceed, and how the implementation will be done. So now we have our plan. We can review this. Plan has diagrams that help us visualize how the code can be implemented, and also gives us, the reference documentation as well, and all the information it has, right? So here we can see we have the ports, the headers, and the pin maps, and what channels it's going to use, how to set up the project, and the API migration map as well, right? And the agents also has test-driven development baked in. So every new feature will also have tests automatically added to it, right? So our test coverage will consistently stay high. And once we finish reviewing the plan, we will click approve and execute, and we can continue with implementation. Now the agent's applying all the code changes, right? So let's take a look at our application C file. Now it's going to build. So after the build, that's where kind of our verification loop comes in, right? So we are building our application, flashing it, and then the agent autonomously reads the serial logs, right? So we can see the serial logs is coming out here. The agent runs the flash and the monitor tool call, which reads the serial logs. And through the serial logs, we can see that everything seems to be correct on the logs, which then the agent recognizes as well and marks the migration as complete. The next step here is I'm going to actually show off some of our hardware interaction features, which will help us further actually verify that the PWM signals coming out on the pins are correct. So I am going to go into debug mode. Currently, I have a picoscope with a built-in logic analyzer attached to my computer. So I'm going to ask the agent to use my picoscope that is connected via D0 to D5 on our PWM pins to verify the PWM signals are being generated correctly. And this is just a demonstration of one of the hardware interaction tools we support. So we support a wide range of tools from logic analyzers, oscilloscopes, power profilers, any kind of test equipment that talks via SCPI, we support. And in each of these categories, we support all the major vendors as well. So as we talked about down here, right, here is the inbuilt serial monitor. And as Embedder makes changes, it will verify its changes with serial logs, right? So we can make sure everything in the program execution is actually happening correctly and our code change is correct. So Embedder can read these logs live and use these logs as basically real world input to see if the code is running correctly on our MCU. Okay, so we have written our picoscope capture, and now we are running our capture. And we can see our PWM signals here now, which has been correctly generated. And we can zoom in. So this applies to oscilloscopes as well and other test equipment where you can see outputs. It's all integrated within the IDE, which is great. And you're able to get this visualization. Right. So this is what we're seeing. And the agent is making sure everything is correct and doing all the verifications. Okay, and through those 3 verification scripts, we have verified through 4 checks that frequency is correct, shoot through is none, dead time is good, and we see enough activity, right? So that is the conclusion of this demo. As a recap, we took existing application example on the last generation AURIX processor, migrated it to a new TC4 or D7 project that only had Hello World in there, right? So we wrote all the application code. Then the agent was able to autonomously first verify that the program was running correctly on serial, then actually use our logic analyzer via the picoscope to verify the PWM signals are being generated correctly on the actual hardware.